equilibrium unit in chemistry. This is one thing that students get wrong quite a bit, just because it's a little bit harder to understand. And that's when you add something to an equilibrium system and wonder what the shift would be if you don't see it in the system. So this is still about Le Chat and shifting. But for example, and we could have taken our data booklet, because this is where we're getting that information from the solubility table. And if you add NaBr in to the system here, you don't see any Na or Br. So instead of thinking you're adding something directly in, you want to think of what are you taking out of the system. So if you're adding NaBr, you would have the sodium ions and the bromine ions, and then we would check page 6 of your data booklet with the solubility table, and it will tell you that silver ions and bromine ions will form a solid. So if we add this to the system, this silver ion will join the bromine ion to make silver bromide as a solid, and we know that solids are not included in our system, and because this is now leaving the system to make this solid, this is actually decreasing. So in terms of a shift, if Ag positive is decreasing, we are going to shift to the left to replace it. So that's our first shift. Here's another example that's a little bit harder. Same idea though. When we're looking at our system, we have the barium ion, the sulfate ion making barium sulfate, and we're adding sodium carbonate to the system. Now, same thing, we can take a look at our solubility table to see what solid will form, and that's the big takeaway here. If you can't directly add something in, then you want to look at your solubility table and see what can you take out of the system instead. So take a look at page 6 and see what ions will form a compound. So this one tells us that barium, when it gets to be with our carbonate ion, it is going to form barium carbonate, which we have here, and that is a solid. So if that's what it's making, it is going to remove it from the system because it needs to be used up to make this compound. And when it is used up, we want to shift to replace it. So once again, you are going to shift to the left. Okay, here is one more, and we have our equilibrium system, and we are adding PO4, 3 negative. Again, this is something that you're not seeing directly to your equilibrium system. So instead, what can we take out? And it's giving us this extra information that FePO4 will form a solid. So when Fe3 positive gets close to this ion, right, they're going to come together and form this solid. So if that is happening, it means Fe3 positive has to leave the system to form the solid. And if you're leaving, you are going to shift to the left. So what is happening to the Fe3 concentration? Well, originally it is going to be decreasing because it is getting taken out of the system, right, to form the solid. Which direction do we shift? We're going to shift to the left. And the reason is because if it's getting taken out of the system, we want to shift to replace it, right? And we'll never replace it to the exact extent, but that's what equilibrium wants to do. It wants to maintain equilibrium. So if we're disrupting the system, we shift to get that balanced once again. So I hope you did find this helpful. Just a quick look at what happens when we take something out of the system. If you're looking for more chemistry help, I do have a website that has all units linked to videos in order, so it can help you study, and I hope that you will. So if you did find this helpful, please subscribe, and if there's any other video I could do for you, just let me know in a comment. Thanks for watching.